Hi, my name's Quinn Olson here at Northwest Rigging in Anacortes. We're working with Skagit Valley College on the King's Pride project. Understand they have the mast out and painted, so we're all very excited to have new rigging. We've got the old rigging in front of us. These particular pieces are the forward lowers. We're replacing this stuff essentially because it's 20 years old. Don't really know how many fatigue cycles have been on it. They're all stay-lock fittings, which is fine, but we're about a thread out from being properly assembled. In addition, when you let the wire sit naturally on the bench, it's wanting to do some things that indicate that we've stretched it a little bit over the years. As we all know, it's better to replace these things before the mast comes down. So we're going to be doing a whole set of new rigging. We're going to show you just a couple of the swages and the process that goes into this, and hope somebody learns something somewhere. So forward lowers for King's Pride, got them stretched out here on the bench where I can pull them straight and get a decent measurement. First thing I'm seeing is that they are port and starboard forward lowers, and they are not quite the same length. We've already determined on this boat that the mast base is slightly off, but in terms of what we're doing, this is close enough I can split the distance on the measurement and rely on the turnbuckles to have plenty of room. We're not that far apart here, about half an inch I'd say, not even a full pinhole. So we'll split the difference, call it good on the measurement. As you can see, I've taped the turnbuckles before the mast came out of the boat, and we can tell that things are still pinned and pretty much as they were. So I think we've got pretty good measurements here. In this particular case, I was the one who tuned this mast when it went in the boat way back in the day for Jennifer and her dad, and yeah, so we're going to build to this length. We'll show you a little bit about how that works when it goes together, but the pieces are this stud and an open body turnbuckle and a T-bolt with toggle. And I do prefer the forged style that are one piece versus the marine eyes. What happens here is you get water ingress in there that gets trapped, and you actually see crevice corrosion happening where you can't inspect it or see it. These are old Navtech style turnbuckles. Haynes now making Navtech parts, but Navtech as a company has been out of business I think for 10-12 years, something like that. Also, with these particular turnbuckles, you tend to see crevice corrosion and bad things happening in between where the stainless is on the bronze thread. I've actually seen examples of these completely blown up. Navtech actually recommended service interval on center screws is 5 years. So if you have these particular style of turnbuckles and you haven't ever replaced your center screws, might think about it. Something good to do at the very minimum. In this case, we're going to replace the whole works anyway. Just easier to start fresh. We can be much cleaner about this attachment than they were. They had a toggle-to-toggle turnbuckle and a marine eye. In this case, I think the previous owner or whoever built this rigging ordered a spool of 3/8 rigging and enough marine eyes to do all the cable, and then did toggle-to-toggle turnbuckles. And he did that for reasons of simplicity, not because things were sized correctly or they were the best solution out there. And this setup actually is a little cheaper than that setup to replicate. So not only are we doing things the right way, we're saving money, which we like to do around here. So we'll have a marine eye at one end and this at the other. We're going to go swage a marine eye onto the end of some 3/8 wire, stretch it out on the bench, and we'll go through matching the lengths up. So one thing we do is put a hole in the side of the spool. So if you are working with spools of wire, that's a nice trick. You drill a hole at an angle that you can stick the end of the wire in to secure it so it doesn't go back spooling on you. So now, it almost happened. So at this point I can either rough cut and waste a little bit, or just stick this in the machine. Give myself a little bit of slack. This is a Fin F4, been featured before in these videos. This is 3/8 wire, so we'll use 3/8 dies. Important with these that you know which side is supposed to go where. In this case, we're putting the numbers in first. And what this machine will do when I turn it on is this is free floating, and there's rollers in here, and there's a little shape like that. So every time this piece goes over a roller, it's a hammer strike. So we'll put the part in there and go boom, 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 just like that. And no, I won't do that again. And we'll have the first swage. What's going to happen here is I'm going to shove the wire in like that till I get to the fitting, and it's going to get violent and loud. So what I've done here, and you'll notice what happened, is I pulled back out, fitting slipped. Got a black mark there, that's the full bury on the fitting. In this case, with this style machine, it's going to shove the metal this way. So it's not actually mission critical that I have the wire cut totally square like it is with other swaging machines. This is also going to leave a mirror finished swage, which we'll see in a moment. No grooves, no ridges. What we're going to do to make sure that this fitting stays on the wire is kink the end of the wire. It's all going to get pushed flat. So this is pretty big stuff, and I usually do it right in my hip like that. Put a little bend in it, and then it gets hard to put the eye over it. Twist in the direction of the lay of the wire. Slide the fitting all the way on to right there. So at this point, we're ready to turn the machine on. What we're looking for here is that the finished product fall in a range, and we're going to measure that and see how close we get. This machine, you're always going to be on the higher end of the range because you're not shoving metal into a part that's not actually the crimp. You're packing all the metal into one tube. This is essentially a tube reducer that they, in World War II, found they could use to make aircraft cables quickly because they weren't standing around talking to a YouTube video. So I've got a table here on this side. We'll be checking that with the calipers. In this case, we are looking for 3/8 wire diameter, which the before swage OD of the fitting should be between 0.703 and 0.698. This is in inches. And after the swage, we're going to reduce it to 0.625 to 0.618. So what we should see with my machine is right at the base of the splice will be about 0.619, 0.620. And as we move up and it shoves the metal, we'll get to that number pretty quickly. And then because we're shoving all the metal, the thickest part of the swage is about 1,000th out of these tables, which once we get fine-tuned, we'll probably be in that. But so we're going to turn the machine on. At this point, you're going to put your earphones on, and it's going to get loud. So the first thing I'm going to do is shove in about this far and just pinch this fitting. So we'll fire up the machine. Just like that. Now check, and you can see how it's already starting to flatten it out. Take the WD-40 grid off. We use the WD-40 because it keeps the burn mark from happening. You can see that it's warm. So, you know, it's about, I got chef hands. So it heats the metal up, but nowhere near what it takes to work hard in stainless. I mean, you work hard in stainless and I did this, I wouldn't have skin left on my fingers. So we're just going to take a little bit of magic wadding polish, aka Never Dull, wax works, clean that up a little bit so it's nicer to handle, and then we'll check. So we've got a pair of digital calipers. Want to make sure they're zeroed, which in this case they weren't. 0. And I am in thousandths of inches, and these actually go past that. So right at the base, we're at 0.619, and as we work up, I'm going to find the thinnest part. So I'd like to be about we'll probably run these one more time. I'm at about 0.626 right there. And that's where the meat starts. As you shove the metal up, you get a little bit out. 0.629, 0.631. Yeah, these need one more trip through. 0.634. So you can see I'm getting thicker up here. So we'll run this one more time through and check it again. See if we can't get about another 2 thousandths out of it.
Make sure the cameraman's got his ears on.
One thing we're forgetting here that is often forgotten, which is pins for the marine eyes. I believe I'm actually out of 5/8 pins, so have to make sure that we get pins. Note that I didn't actually twist these, and that's because when I go to lay them out, I don't want to have to untwist them, because I'm going to hook these right to the mast and then unroll this, so I don't want to have to unspool things as I'm doing that. So we'll use zip ties to secure this. Of course, I'll have to be slow with these zip ties because it's on camera. So your armpit is a useful tool. You're going to edit that little stumble out too?
We're going to leave that one in.
Leave that one in. If you've got a bigger zip tie, it's a little nice, but this will work, I think. Yeah, hold on. There we go. So this is ready to go to the boat. If I was shipping, I would do more zip ties, get the coil a little smaller. In this case, we're going to stick this in my trunk and take it over to the school and put it on the boat when it's ready to go. So it just needs to stay secured while it's on the floor and not kill anyone. Maybe one more. We'll do one more because it's going to do that. That's pretty normal. It happens. My zip ties aren't big enough to double up on the 3/8. So if it's not behaving, just make it behave. There we go. These go on the floor because they're done. And at this point you ask the client, what would you like me to do with your old rigging? That's actually a question. What are we doing with the old rigging? Recycle?
Yes.
See that this is a little more unruly than the new stuff. And this I'm going to twist. Oops. Whatever. Oh, deadbolt. Turn around. Anybody got a flatbed? My box still. We're gonna trade that for an I-beam. So we'll be ready to do the next pieces, which I'm gonna wait on right now.